Now, the final part, which we're going to talk about, is how we can make it faster. So again, I think I mentioned before, we're not going to kind of do a deep dive about how you design Tableau workbooks in order to make sure that their performance. We have another session next week. Here we're going to talk about some basic strategies for how you can actually scale your Tableau server deployment and actually make the server itself faster, as opposed to making the workbooks faster. So the first thing that you can do is you can scale up the server. This is a quite simple one. So perhaps if you have an 8-core server, you don't have enough memory. It might be that perhaps you're virtualizing your hardware, or you use a cloud provider. You can simply add more hardware to that, and that will allow you to actually to account for more users. A very important thing when you're actually scaling up Tableau Server is that if we actually look at the processes that are installed with Tableau Server, if I go back to my very first slide, what we see here is the number of processes that are installed for Tableau Server. So we can see we have 2 SQL servers, we have 2 backgrounders, and we have 2 data servers. Now, the counts of these are defined by what's called default process counts. So when Tableau is being installed, it looks at how many processor cores your server has, and then actually decides how many of these processes to install. If at some future point, if you actually were to power down your server and actually resize that dynamically and restart it, and Tableau Server itself wouldn't actually automatically add more processes to here. So you'd actually need to add those processes manually within what's called the TSM interface. Now, the TSM interface is the interface that you effectively saw. Let me find the slide. What we saw here, and you see that these process counts are actually configurable. So in this case, I can see that I've specified 4 SQL servers, 2 cache servers, 2 backgrounders, and 2 data servers. So again, if you do want to scale your hardware up, you're going to need to consider actually adding some more of these processes in order to utilize that hardware. Okay, so we mentioned about scaling up. So the next thing is that you can scale out. So once you kind of reach 16 cores on a particular machine, you get more performance benefits by scaling out to different machines, as opposed to just adding more resources to a single machine. So for example, if we look at this deployment here, we can see a deployment which has been scaled out to 3 nodes. So down on the left, we have a list of all the processes. On the top, we have the 3 nodes that are actually included within Tableau Server, and then we have all the process counts that are configured within each node. The good thing about scaling out is that if you have a particularly heavy workload that occurs on one of these nodes, then it won't affect the performance of users that are accessing the particular nodes. So perhaps you have one dashboard which performs quite poorly because the calculations are quite complex. If, as a user, I actually view that dashboard on one of these nodes, and then the other users who are actually attempting to view dashboards can be allocated resources from other nodes. If I only have a single node in my deployment, and actually my complex action is consuming all the resources of that node, and there's no isolation that allows those users to kind of have their experience preserved by accessing another node. So this is a case of a scaled out deployment. What we also might want to do is actually scale out and separate the workloads. So here is an example of a deployment. Now what we see is that we have a single node which has 4 SQL servers. So these are again, if we cast our mind back, these are the servers which are actually rendering the dashboards for the users. But we have 2 separate nodes, and these nodes contain backgrounders. So in this case, we have 2 nodes that are dedicated to performing background tasks of Tableau. So this could be things like refreshing extracts, or actually running Tableau server flows. And then we have 1 node which is dedicated to viewing dashboards. Now this could have big performance benefits if you're having to refresh extracts and perform flows during the day. Perhaps you know that these nodes are going to be very busy and that the resources on these nodes are going to be entirely consumed, and you don't actually want to affect the user's experience of loading dashboards. because all the background work's being doing on nodes 2 and 3, and node 1 is preserved for actually that dashboard interactivity. Where this might not be a particularly good use case is if you know that all your extracts are going to be performed outside of business hours, but your dashboard viewing is going to be performed inside of business hours. In this case, these two servers are going to be very, very busy at night and very quiet in the day. And then node 1 is going to be very busy in the day and very quiet at night. So then you're going to have a lot of underutilized resource on your background nodes during the day and on your front-end node during the night. So if that's the case, and you know that your extracts and your dashboard views are occurring in different places, then you might actually want to have 3 nodes that have both backgrounders and front-end processors, so that you can actually be making the most of your hardware during the night and during the day. Now, the final performance strategy from a Tableau Server point of view is to handle your compute when you're storing the information and not when you're querying the information. So again, this kind of architectural approach from Tableau Blueprint shows how you might actually be handling your data flow. Is that you might have a raw data source, in this case shown in green. You might be performing some computations during your preparation process. So perhaps you're calculating aggregates, perhaps you're calculating dynamic date ranges, etc. And then you're storing that information. And then when the user is actually viewing the dashboards, then there's additional computation being performed before the dashboard is actually rendered. Now this is important because any computation that you use for data preparation, you can perform on your own schedule. So again, that can be outside of business hours, or that can be something that's happening on a regular basis when the user isn't doing a dashboard. But the compute for query, this is always going to be carried out as the user is actually doing the dashboard. So if you know that there's a calculation which always has to be performed, rather than perform that calculation every single time when the user views the dashboard, it's better to perform that out of hours, so that when the user actually accesses the dashboard, that calculation is already performed, the information is already stored ready for the user, and then that information can be retrieved straight away, as opposed to actually that calculation being done as the user accesses the dashboard. And again, this is very much the way that Hyper works, is that we might have a raw data source. We might be doing some preparation. That information is being loaded into Hyper, and then that Hyper extract is being queried, and there is some computation there as the user views the dashboard. Now, it might be that not all of your calculations can actually be performed before the information is stored. Perhaps one of those calculations is the result of a parameter which is being added by a user, and you don't know what that parameter is. So again, you're going to have to do some compute when the user is actually querying the dashboard. But the more you can do within the preparation stage, the snappier the response of loading your dashboards is going to be. Okay.